Hello everyone, today we are going to see the one more example of a CNC part programming. In last lecture we have seen the CNC part programming for the turning operation. Now here you can see the raw material. It is a plate having 65-70 mm thickness, okay, which is a raw material on left side, and the right side that is a finished product. Okay, this is what we want. Okay, but if you observe finally the finished product, we are supposed to do the two operations. Okay, first one that is milling operation, and another one is drilling operation. Okay, and for this we are using a 12 mm diameter end mill cutter for milling operation, and for drilling operation we are using the 6 mm diameter drill bit. Okay, so for this we are going to do the two programs, first for the milling and another one is for a drilling. Okay, so first let us see the programming for the milling. Okay, I already did the programming over here, so you can see. So here you can see the programming for the milling operation of this part. Okay, so let us see one by one. Okay, so here the first line, that is G55 X200 Y80, this is a work coordinate offset is there. Okay, and below that program one, that is a program identification number. Okay, and here our series starts, sequence number starts, that is from N001. Okay, but you can also use N0010, N0020, N0030, N0040, N0050, N0060, N0070, N0080. Okay, as we have seen last time that we can program in that way also. We can maintain the gap of 5 or 10. Why? If we want certain modification in that program, then we can insert that block in between them. Okay, and if there is nothing to change, then you can do in a regular way by this way. Okay, so first let us see the N001 block. Okay, so N001, it is nothing but a sequence number of the block. M06 is for a tool change, that is we are going to change the tool with a end mill with diameter of 12 mm. Okay, and T1 is a tool number. Okay, the end mill cutters tool number is 1, that we are assuming in this programming. Okay, so as we have changed the first the tool with end mill cutter, now second block N002 M03 RPM 400. Okay, N002, it is sequence number. Remember N001, N002, N003, these are the sequence number. I am not going to repeat it again, so you keep in mind. In N002 second number block, M03 is there. M03 means it is a spindle rotation. Okay, so in this, spindle is going to rotate in clockwise with 400 rpm. This is the meaning of this block. Okay, so first of all we have changed our milling cutter, and we have given the instruction it should rotate clockwise, which is having a 400 rpm. Okay, now the next block N003, here G01 is there, it is for a linear interpolation. Okay, x minus 8 y0 z0 xy feed 150. That means we are going to save position with the tool is going to save position with feed 150 mm per minute. Okay, now here, as you can see, first line over here, that is G, if we have selected the work coordinate offset. That means we are setting the datum to the lower left corner, okay, of the workpiece. Now we're going to see the fourth block, that is N004 Z01 X8 Y0 X minus 8 Y0. That is, we have seen the, okay, let's see the N003, that we have seen the, it goes to the safe position with speed 150 mm per minute. Now next, that is N004 G01 X minus 8 Y0 Z minus 0.5 Z feed 150. That means lower the end mill to determine the depth of cut. Okay, now next, that is N005 N005 G01 linear interpolation X70 Y0 Z0.5 X5 feed 75. Okay, that means the tool move from the from the lower left corner of the workpiece to the right lower, okay, one cutting with feed 75 mm per minute. Okay, in fifth number, the cutter is moving from lower left corner to the right lower corner with feed 75 mm per minute. So first pass is in such a way. Okay, now let us see in next block, that is N006 Z01 X70 Y60 Z0.5 X5 feet 75. Here you can see X70 is here. Now toes position is over here. Now we want to cut in Y direction in this way. Okay, so cutter should move from here to here. That means X70 and Y60. Okay, but before this, you can do one thing. You can also note down the different position of the cutter also. Say from here to here, then here XY number coordinates, then here you can write down the XY coordinates, and further here you can write in such a way. Okay, so we are at 6 number block. Okay, here our cutter is moving from here to here in 6 number block, that is move from the, that is, here you can see our cutter is coming, sorry, cutter is moving in this direction. In Y you can see the coordinate X70 Y60. That is the move of the cutter from low right corner to the upper right corner. Okay, in such a way we can move a cutter. So here you can see N06, our cutter is moving from N70 N70 to N70 60 over here. Now our cutter is now here, okay, after N006. Now here, now we are moving our cutter towards the left side, okay, that is from N7060 to N3060. Okay, now let us see N007, that is G01, X30, Y60, Z0, Z minus 0.5, XY, feed 75. That means cutting the horizontally up to 30 mm. Okay, now after that our cutter is now over here, and if you see incline cutting is there, so here you can see the next N008, Z01, X0, Y40, Z0.5, XY, feed 75. Now cutting is from 3060 to 0Y40. Okay, so here in such a way cutting is performed. Now again, after this we are supposed to move cutter from here to lower left corner. Okay, so as you can see over here in N008, that is our cutter is moved inclined, and our cutter is over here X0, Y40. Okay, and here now we are going to move the cutter in downward direction, that is N009, G01, X0, Y0, Z minus 0.5, XY feet 75. Okay, now our cutter is moving from here to here at lower left corner. Okay, so this is what our one cut. Now we're supposed to repeat this cycle, okay, up to the depth. Here the depth is not mentioned, so uh, let us say 4 mm depth. Okay, now this cycle is this cycle should repeat 7 times. Okay, or this block should repeat 7 times from N003 to N009. Okay, hence the next block is there N010, Z81, R3, E9, N7, Z minus 0.5. That means repeat 7 times block from N003 to N009 with incremental offset of Z minus 0.5. Okay, so I'm repeat once again. So initially you can see over here X is kept at -8, Y0, Z0. Then second position you can see over there. First of all, we have selected the tool in first line, selected the tool, then we have given the spindle rotation. It should rotate clockwise with 400 rpm. Okay, then after that we have shifted to the shape position. Okay, whatever our milling cutter is there, end mill cutter is there, we shifted to a safe position. Okay, and after that we reduced the depth. Okay, first of all we selected the tool, after that we decided the spindle rpm. Okay, and it should in clockwise direction. Then we placed the cutter at a safe position with a feed of 150 mm in xy plane. Okay, after placing the safe position we reduced or we lowered we lower we moved the cutter in lower direction, that is Z direction. Okay, still our cutting operation is not started, our machining operation is not started. Now after reducing the height of the cutter or the determining the depth of cut. Okay, first of all we have shifted to the safe position. Now we reduced the depth, we uh, lowered the end mill cutter, that is we have given the depth of cut to the mill cutter. Okay, and after that we started the we have given the instruction that the cutter should move horizontally. Okay, so here our previous position of the tool was x minus 8 y0 z 0.5, that was the n004. Now in next block we are giving the instruction that the cutter should move horizontally, so the coordinates are going to change, that is x will be the x70 y0 and having the z, that is 0.5, that is the depth of cut. Okay, and feed and the with the feed 75 per minute. Cutting with feed is 75 per minute. Okay, after finishing the horizontal cut, now we are supposed to move the cutter, that is from lower right corner to the upper right corner. So again the coordinate will change, that is from x70 y0 to x70 y60. Okay, after this moment, now we are going to move the cutter from right lower right corner to the upper right corner. That's why we have given the instruction, or we inserted the block over here, that is the cutter will move from from x70 y0 coordinate to x70 y60 coordinate. Okay, with the feed of 75 per minute, and after that we are going to move the cutter in horizontal direction. Okay, that means its coordinates will change from x70 to to x30 and y60. Okay, so here our next block is there to move the cutter from upper right corner to towards the left side. Okay, because after that the inclined cutting is there. Okay, now our cutter position is over here, that is x30 y60. Now we are going to cut the inclination. Okay, now here it is x30 y70, and now here our cutter moves with x0 y40. So here you can see n08 g01 x0 y40 z minus 0.5 x5 feet 75. Okay, that is here you can observe, that is where maintaining the 75 per minute speed, cutting speed throughout constant during cutting operation. Okay, so now we came over here x0 y40, and after that here one last cut is there of the milling cutter, so it should move from x0 y40 to x0 y0. Okay, so here you can see the next, that is z01 x0 y0 z minus 0.5 x5 feed with 75 mm per minute. Okay, and after that it should be repeated this cut, because only one cut is not sufficient, because we have given the feed 0.5 mm. Okay, and the depth of actually the cutting depth is 4 mm. Okay, and that means as 0.5 is already over, now it should move, it should repeat the 7 times. Okay, so for that we have inserted the, we have used the code G81 J81 R3 R9 R3 E9 N7 Z minus 0.5, that is the depth, with the depth of cut 0.5 mm. Okay, that means repeat 7 times blocks from N003 to N009. Okay, with incremental offset Z is equal to 0.5. This is what the milling operation we have performed over here. Okay, and after that now the cutting operation is performed. Okay, whatever the spindle rotation, as in here we have given this spindle rotation, now we are supposed to stop the spindle, that is the spindle should be off, so we have used the M05. Okay, so M05 for the spindle off. Okay, now as we know our cutter is now here, and whatever the cutting operation with the help of end mill cutter is performed, so here our program is over. That's why we have used the M02 at the end, that means the end of program is there for the milling operation. Okay, here you can see last N012, this you are supposed to write sequence wise. So to perform the operation, however the number of these sequence is required, don't bother about it, you are supposed to give the instruction one by one. Okay, as here you can see, first we changed the tool, then we have given the spindle RPM clockwise direction, then we moved to the shape position, then we given the depth of cut in next block, then we started the cutting operation or machining operation, one horizontal cut, then in next block the vertical cut in y direction, and in next block it is partially horizontal cutting operation, and in next block the incline cutting. Okay, and after that the vertical downward direction the feed was given. Okay, over here if you observe over here, here the value of only x and y is varying over here, and while cutting the z value is throughout constant. Okay, here you can see z, you are supposed, it depends on you how much depth of cut you are going to use, that is either 0.5 or 1 mm, it depends on you. Okay, and you are using a feed that is 75 mm, it is also depends on you. Okay, this normally give this normally gives in the question itself by using use such mm per minute, or use the depth of cut either 1 mm or 0.5 mm. This was already the given data. By using then that given data, you are supposed to use the values over here of the feed. Okay, so if you see over here, G0 is there throughout the block, as initially from where the cutting is, here you can see for the tool moment. Okay, they moved the tool linear movement. Okay, G01 is used for a linear movement of the tool. Okay, and G81 it used for repeat cycles. Okay, that the repeat the blocks from N0032 to N009 with incremental offset of 0.5. If you observe here, Z direction is in downward direction. Okay, that's why minus is there. Okay, and if you see over here, X, as you can see, X is in this direction, Y is in this direction, and Z is the end mill cutters spindles direction is a Z direction. Okay, that means if you want to give the cut, the spindle axis should be either it should be moved in downward direction, and its downward direction is nothing but a minus. Okay, this is what the programming of for the milling operation. You can see it is very easy. You can try to solve by changing the value many times. Okay, then you will get the idea of this of the part for the milling operation. Lastly, I am going to repeat it once again. Okay, so here in first line, okay, we set the datum to the lower left corner of the work over here. Okay, then this is program number. Then we have selected the tool M06, having its tool number is 1. Then we have given the rotation, we have given the instruction that the tool should rotate, the spindle should rotate in clockwise direction with 400 rpm. Okay, and after that we moved this tool to the safe position. Then we give the depth of cut in next block, that is in fourth block. Then we move the cutter in horizontal first cut. You can see over here it moved, that is it should move x70y0 over here. And after that, that is the shifting from the cutting is from lower left corner to lower right corner. And after that, now we are going to move the cutter from lower right corner to upper right corner. That means the coordinate should change, that is from x70 to x70y0 to x70y60, as you can see over here, x70y60. Okay, with speed of 75 mm per minute. And again we moved horizontally. Okay, that is x30y60. Then we moved in inclined direction, that is x0y40. And last cut, that is downward cut, to move it into the original position, and that is n009 x0 y0 z minus 0.5 with speed of 75 mm per minute. And after that, we are going to repeat this cycle. We are going to repeat this cycle from block number 3 to block number 9 with incremental depth of cut of 0.5 mm. Okay, and after this we are going to stop the spindle speed by using M05, and at the end, that is the end of the block, with the help of M02. M02 is for the end of the block. If you observe here, there are main three parts are there in this programming. Okay, first is the program setup. Okay, program setup, that means we do the tool change, spindle movement in clockwise, its rpm. That was the first part of this of any programming, that is a program setup. Second part is a chip removal or the cutting operation, which is performed over here. Okay, and third one is system shutdown. Okay, here you can see the spindle off, turn the spindle off, and the end of block or program should stop. That we can use in system shutdown. Okay, so in part programming there are three main part, that is program setup initially, in middle the chip removal is there, and last one is system shutdown. Okay, that's it. Today we're going to stop over here. In next lecture we will see the drilling operation for these three holes. Okay, thank you.